Day 406 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 337, House Robber 3. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. The thief has found himself a new place for his thievery again. There's only one entrance to this area called root. Besides the root, each house has one and only one parent house. After a tour, the smart thief realized that all houses in this place form a binary tree. It will automatically contact the police if two directly linked houses were broken into the same night. Given the root of the binary tree, return the maximum amount of money the thief can rob without alerting the police. All right, y'all. So the house robber is back again, and this time he has a new neighborhood that he's robbing. This neighborhood is a binary tree, and we're about to go through these examples just to make sure that we are understanding this question correctly. So in example 1, we have the input root equals a binary tree 3, 2, 3, null 3, null, and 1. The output is 7. Explanation says the maximum amount of money the thief can rob is equal to 3 plus 3 plus 1, which equals 7. So let's take a look at this picture just so we could get a better visual representation of what's going on. So the house robber starts here at 3, at this root node 3. Boom. He can't rob this root, or he can't rob this node because this node is directly linked to the root node, right? So if he robs two directly linked houses at the same time, then it will automatically contact the police. Boom. So he can't rob this house and he can't rob this house. He starts with this house, he has to skip this house, and then he robs this house. Boom. So now he's robbed this house and this house, that's $6. Boom. But he also has another house that he could possibly rob in this binary tree neighborhood because there's another leaf node over here, right? So he could skip this node because it's directly attached to the root node, but after skipping this node, then he can still rob this node. So that'll add another $1 to the amount that he can rob in total. So in total, he can rob 3 plus 1, which gets him $7. He has to skip these two nodes because if he robs this node first, these two nodes are directly connected or directly linked to this house that he already robbed. So he has to skip over these two nodes right here and come to this node and this node. So I hope that made sense to y'all, but just in case it didn't, let's take a look at example 2 so we can get a better understanding of what's going on. So in example 2, we have the input root equals the binary tree 3, 4, 5, 1, 3, null, and 1. This time the output is 9. Excuse me, y'all. Explanation says the maximum amount of money the thief can rob is 4 plus 5 plus 9. So in this neighborhood with this binary tree, he decides to skip the root node because that will mess up the maximum amount he can rob. Because if he robs the root node first, then he can't rob this house with $4 and this house with $5. He would have to come down here and rob a house that only has $1, house that only has $3, and a house that only has $1. So if he robbed these 3 houses down here, that get him 5 in this root node, that get him 8 in total. When he could just skip the root node and skip all these houses down here and just go straight to these nodes and rob this house for $4 and this house for $5, that'll get him $9, and that's the maximum that he can rob. So that's what he's going for. So I hope that made sense to y'all. As you can see, once again though, just to really make it make sense, as you can see, none of these nodes, including this node, are directly connected. These two nodes are not directly connected as well. So I hope that makes sense to y'all. And now that we understand the question, y'all, let's get into the fun part, the actual solution, y'all. Solution, not that difficult. Let's get started. Now, the first thing we're going to do is we're going to create a helper function to perform a post-order traversal, meaning we're going to go from the bottom up. So for that, we can declare a variable. We can say func. It's going to be a nested helper function. So we're going to say, meaning it's going to be inside this main function. So we're going to say func DFS, open up the parentheses, underscore node, colon, tree node, boom. Then we're going to put the put a question mark, and it's going to return, boom. We're going to open up parentheses, and we're going to say Rob, colon, that's going to be an integer. And so Rob is going to be the max amount if we rob this node, and then we're going to say comma skip, colon, that's going to be an integer as well, and skip is the max amount if we skip this node, or the current node that we're on. Now we're going to create a base case. If the node is nil, then we can return 0 for both rob and skip. So we're going to say guard let node equal node, else we could just open up the brackets and we could return 0, 0 for rob and skip. Boom. Then we're going to recursively compute for the left and right subtree. So we're going to say let left equal DFS, open up the parentheses, node.left. Then we're going to do the same for right. We're going to say let right equal DFS, open up the parentheses, node.right, just like that. Now, if we rob this node, we cannot rob its immediate children. So for that, we have to say let rob equal node.val plus left.skip plus right.skip, just like that. Boom. And if we skip this node, we can choose to rob or skip its children for the max value. So we're going to come underneath this. We're going to say let skip equal max, open up the parentheses, left.rob, comma, left.skip, come outside of these parentheses, and we're going to say plus max, open up the parentheses. This time we're going to say right.rob, comma, right.skip. Boom, just like that. Now we need to return a pair of values for this node. So we could just come underneath this and we can say return, open up the parentheses, rob, comma, skip. Boom. Now we're going to come outside of it. That's just our helper function, right? So now we need to come outside of the helper function and call it in the main function. So we're going to say let result equal DFS, open up the parentheses, root. Then we're going to come underneath that and we need to return the maximum number of robbing or skipping the root. So for that, we come right here and we can say return max, open up the parentheses, result.rob, comma, result.skip. And that's going to return whichever one. This right here is going to return whichever one has the maximum value, result.rob or result.skip. So that's all the code, y'all. It wasn't that much. So let's go ahead and give it a run. Make sure it runs properly before we submit it. Ooh, okay, so we have an error. Let's see. Oh, we spelled guard wrong. So let's fix that. And let's run it again. Let's see. Okay. Oh, that's the same error. So let's see. Oh, so these should be in parentheses. These zeros right here should be in parentheses. So let's put those in parentheses and run it again. Sorry about that, y'all. And it's accepted. So let's go ahead and submit it. Make sure it stays accepted after we submit it. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are the numbers I like to see. So with that being said, y'all, make sure you go over the code again, read it, learn it, love it, internalize what's going on. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.